Hey, Hamburger,
Well,
how are you?
yeah, I'm doing good. Raven, nice to
Cool.
meet you.
Yeah, good to meet
Cool.
you.
Yeah. So today it's a Facebook practice interview. It's the session is 1 hour, but the actual interview for Facebook it actually takes 45 minutes. But we can
Got it.
use the whole time, 45 minutes, and then the end to discuss anything regarding if you have any questions or we can discuss feedback. Yeah,
Okay.
that's the format. Yeah, and for the interview, that's 45 minutes. They they usually have two questions. That means you have about 20 minutes each for each question. And most importantly, they do not allow you to execute the code. So we're gonna run the code by hand.
Okay.
We're not going to hit the run button. All right. So may I ask if you have scheduled or if so, which route that you have with the Facebook?
Yep. Yeah. So, I've been doing a lot of practice, by the way. So this is, I was just getting a few in for the weekend. My interview's on Monday, and I'm pretty much expected to already be prepared. I just, thought, why not? I have a little bit of time.
Yeah, practice makes perfect. So let's get started. I'm going to
Sure.
paste. Oh yeah, you can choose any language. You already chose Python. That's great.
Yep.
So let's get started. I'm going to put this example input and output. Um, you are given a string input, and then you determine if this string can be removed any one character, and it will be a palindrome. So if you can make that a palindrome by removing one character, then you return true, otherwise false. For example, you can remove S here to make this string a palindrome, so you can return true. You can either remove this string or this string, make it palindrome, so you return true here. But the last example, you cannot make it a palindrome by removing any character. So that's the question.
Okay. Got it. So we're going to be returning basically true or false if we can remove a single character. If we have an empty string, should I return a default value?
Let's return true.
Okay. I'm just going to write the function signifier first. So is palindrome with one char removed, and we'll have some input string, and this is going to return a bool. Okay. I'm thinking of some other clarifying questions here. Empty string is a palindrome. Is that correct?
Yeah, that's correct.
Okay. Then I'll just put our guard statements, and fact, I should say, we'll say less than or equal to 2. Because if we have two characters, then we remove one, we have one character. Okay,
Yeah.
so I'm going to think about my strategy here for a moment. So, okay. Um, maybe I'll just sort of talk about the first approach. I don't know if this is going to lead anywhere. So we have taco cats, and maybe I have 2 pointers, one at the beginning and one closer to the end of the string. So if these two values are not equal, then it would mean that I would probably have to end up removing one or the other. And if we end up removing one, then we can just do a very quick palindrome check in linear time. Um, but okay, but then the question is really going to come down to, well, what if we have another case here where we have I'm trying to think of what the time complexity of this is going to be. So these pointers are going to come inwards. We are only going to remove a character once. And then when we do remove a character, we are only going to check once if something is a palindrome. So the total amount of time these pointers might be incremented or decremented is going to be linear. So it's going to be something like n plus let's see, the palindrome check is probably going to be 2n, just because we have two different scenarios. And okay, so I think this might be linear, but I'm trying to think of any special edge cases here that's gonna make this a bit more challenging. What about a scenario like, okay, let's say A, B, C, D. If we were to apply this algorithm, then we would look at A and D. They don't match, and so clearly we're going to have to remove one of them. If we end up removing D, then we have A, B, C, and we can very quickly see that this is not going to be a palindrome, and same with B, C, D. We can check that as well. If we have a true palindrome, like let's say something like this, bunch of A's, but it's odd. Okay, so in fact, I'll just have 3. We know that this should return true, but what I currently have is eventually these pointers are going to end up being set to the middle value, and we know that in this case there's an odd number of characters, and so in this special edge case we know that we're going to return true. And if we had 4 characters here, and these start decrementing and incrementing, eventually they're going to pass each other. And so I guess if we do remove a character, it actually still is a palindrome. If they end up passing each other, then the question is which character should we remove? And I don't think that's necessarily an easy question to answer here. So let's say we had, let's see. If it already happens to be a palindrome and has an even number of characters, I'm trying to think of how we would know to remove. Well, if it's even number of characters in a palindrome, the 2 middle characters are going to have to be the same. And if we remove one of those middle characters, then it's going to be still a palindrome. So we can say
one thing. If the string is already a palindrome, you can also return true. That means you don't have to remove that one character. If it's already a palindrome, it's just return true.
Right, sure. So another check here, def.
Yeah, it's like removing at most one character. So that means you can just keep all characters if it's a palindrome. I hope that helps.
Okay. Cool. So I think the algorithm I have, I think it might work. So, all right, I can go ahead and implement this. I think linear time complexity is acceptable. So I'll just start writing out some of the parts of it. So we have our 2-pointer approach. We have I is 0. We have J is len, string -1. And let's see. When we come to, I'm trying to think of how to process this correctly. When we come to a point where 2 characters are, the pointers I and J end up pointing to some character that doesn't match and we want to remove it. I'm just trying to think of how we're going to process it. For our race car example, it's going to be E and it's going to be R. So yeah, I can just make it very simple. We'll end up using constant, or I have an approach that's simple. We'll use linear space, and I'm wondering if that's acceptable to you, or if you want to make sure that it's only constant space.
Let's try and see. I think linear space looks good. You have to check the characters, right?
Okay. Right. Okay. So then what we could do is, let's see. We want to say while string, while I is less than J, and string at I is equal to string at J. I want to say I plus equals 1, J minus equals 1. So down here, we have I is equal to J or mismatched characters. So, okay, if I is equal to J, in that case, let me put less than or equal here. because I'm trying to think if I want to do that or not. If I is equal to j, and the string is odd in length, then we can just remove it. So if I is equal to j and len string mod 2 is equal to 1, then we can return true. And in the other scenario, where I is equal to j and the length of string mod 2, or the string length is even, then what we can do is that should actually not be possible. I will not actually equal j if the string length is even. They'll actually cross over from each other. So I'll say if I is greater than j and len string mod 2 is equal to 0, then we can still return true because the two middle characters will be the same. And if we remove one of them, then everything will still work out. So the scenarios here that I'm interested in is when I is less than j and these two characters are not equal to each other. So we've already checked if something is a palindrome for the outer characters. So we should only need to check the subset of the string between I and j. So we could say if is palindrome. In this case, we're going to start at string at I colon j. It will not include j. So that will be like removing the j character. Is palindrome string I plus 1 colon j plus 1. Let me just put a comment here. I'll remove j character. In this case, remove I character. And if we get down here, we can return false. So do you want me to implement is palindrome? Actually, I can probably do it really quickly. Reversed string is string dot reverse. I think actually there's another notation I can use. That and return string is equal to reversed string. Okay, so let me work on a manual test case, and I'll try race car. I like that one. So we've got race car here. Let me just put a comment block. Our string is racer car. Right, if not string, okay. If length string is less than 2, return true. And if is palindrome string, okay, as far as is palindrome, this isn't a palindrome, so I'm just going to skip over the evaluation of that function. And we have I is 0, we have j is length of string, so this is 1. Let me get the indices here, 0, 1, 2, 3, 4, 5, 6, 7. So it looks like that's 8 characters, so the length minus 1, 7. And we have some while loop. Currently, let's see, I is 0, j is 7. And let me put another two variables here. We'll say this is I, and we'll say this is j. So r, okay, string at I is r, string at j is r. So they are equal, I is less than j. And then we increment I, and we decrement j. Whoops, that was 7, this should be 6. So, all right, we're going to try this again. I'm going to increment I visually, decrement j visually. So, all right, I is less than j. String at I is a, string at j is a. So we're just going to increment and decrement. You're going to increment again, decrement j again. I is still less than j. String at I is c, and string at j is c. So we're going to increment and decrement. Cool. And in this case, I is less than j, but the two values are referenced are not equal, so we're going to break out. We have if I is equal to j and the length of the string is odd, we're going to return true. If let's see. If I is greater than j, which is not true. So then what we're going to do is we're going to try to run our isPalindrome on two substrings. So isPalindrome at, let's see, race car starting at index I and ending at index j minus 1 is just going to be E. So we're going to remove the j character. And E is just one character. This definitely is a palindrome reversed, so we're going to end up returning true. So we return true. Okay, it works at least for that test case. I could try and come up with some other edge cases, or I'm not sure if you have some other ideas in mind.
You try the negative case, like the case that will return false.
Okay, so we'll do A, B, C, D. Do this real quick. We have string is equal to that. And okay, length of string less than 2 is false. Is this a palindrome? It's also going to be false because reversed is going to be DCBA. And we have I is 0, J is, length of this is 4. 1, 2, 3. Okay, and we have I is going to be 0, J is probably going to be 3 because it's the length minus 1, so that's 4 minus 1, 3. And okay, so we have some while loop. We have I less than j, string at I as A and string at j is D, and so they're not equal, and we're going to immediately break out. And the I is equal to j check is not going to work. I is greater than j check is also going to fail. So then we're going to check is palindrome. String at index I to index j minus 1 inclusive, so that's A, B, C. So this is going to be our first check. We're going to do our reversed string is C, B, A, and then we're going to return A, B, C is equal to C, B, A, which is false. And then we're going to try is palindrome. It's going to be index I plus 1, so that's going to be starting at B, and it's going to end at index j inclusive, so B, C, D. And then our reverse string is going to be D, C, B. And we're going to return B, C, D is equal to D, C, B, which is false. So then we're going to be on line 83, and we're going to return false.
Okay, good. What is the space and time complexity?
So the time complexity is going to be linear. Reason being is that in our loop line 72, it's going to be linear time there. And then we're going to call is palindrome on line 80, which is also going to be linear, and same with 82, and same with 68. So linear time. As far as space, it's also going to be linear because on line 81 and 83, we're getting a slice of the string, and this could be up to the size of the entire string. Also, within our isPalindrome function, our reverse string is a copy of the string. So linear time, linear space.
You make the linear space better?
Yeah, that is definitely possible. So as far as linear space, so the isPalindrome function, I could have a two-pointer approach to make that linear. I don't know if you want me to actually change the code for that. And what we could do for our isPalindrome function, we could do this: def isPalindrome. We have our string, and we have our start, and we have our end. So we're actually looking for a palindrome of a subset. And then what we do is we have, I'll call this isPalindrome 2. It's while, start is less than or equal to end. If string at start not equal string at end, we would return false. And then we would adjust. We would say start plus equal 1 and minus equals 1. And if we get down here and break out, this means we can return true. So then what we would do is we'd modify is palindrome to contain our string and then our start and ending indices. So that would make it constant space, since we wouldn't be allocating any more memory. So I could make those modifications if you want, but I'm not sure if you want to move on to the second question. So
Yeah,
this would be
this one
string.
looks good. At least you understand that the palindrome is the bottleneck, and you can do it. So that's great. Yeah, like I said, I'm going to move on to the second question.
Okay. Yeah, let's go ahead.
Okay, let's go ahead. I'm going to test the question above. So this is to get the input as a string again and output as a string. So the question is, given the string of parentheses, and that could be some characters as well, your job is to balance the parentheses. That means by removing as few characters as possible. That means you cannot add any parentheses to make it balanced. So let's go to the example. The first example is already a balanced parenthesis, so you don't remove anything and just return as is. But for the second example, in order to make it a balanced parenthesis, the only way is to make it empty, because you cannot add any more brackets. So you can only remove them. So empty string is the answer. And same as the third example. And for the fourth example, you got to remove the first and the last parenthesis to make it balanced like this. And for this one as well.
Right.
And there can be multiple correct answers, like these two examples. So you return either of them. It's fine. Just make sure that you remove the fewest characters as possible.
Totally. All right.
Yep.
Yeah, I think I understand this question. So I know in a single pass, I can remove unnecessary closing parentheses. The way I can do this is, let's say we have a running counter for that. We'll every time we encounter an opening parenthesis, we add 1 to this counter. If we encounter a closing parenthesis, we subtract 1. And then what happens is, whenever our balance would be negative, we know that we have too many closing parentheses, and we would just sort of not add it to our result string. So in a single pass, we can get rid of all the unnecessary all the unnecessary closing parentheses. What we can do is repeat this process, scanning from right to left as opposed to left to right, to repeat this process for the unnecessary opening parenthesis. And then whenever we encounter some other character that's not an opening or closing parenthesis, we just make sure to always include it in the result. And the time complexity for that is going to be linear, 2 scans. Space complexity is also going to be linear, because I'm going to need some, result to work with. I don't think there's a way that we're going to be able to, with a lot of effort, it might be possible to do it in constant space, but I think linear should be fine. So that's cool with you. I can go ahead and start coding it.
That's good.
Okay, so we want to say balance, parentheses, and we'll have our, string as input. And okay, so the first thing I just want to do is, if not string, then return, empty string. And I think that's the only initial edge case to worry about. So, all right, as far as these 2 scans, I might want a, let's see. Well, I'll write it out without a helper function, then I'll try and include a helper function. So I'll have a weights dictionary. And opening is going to be 1, and closing is going to be -1. Okay. So why is this complaining? All right, it's not used yet. So, well, partial result, we're just going to keep that as an array. And so for char in string, if char not in weights, which means it's just a character, we're going to do partial result dot append char. Simple. And we continue. So we also need a weight sum, start at 0. So if char char is equal to opening parenthesis, in this case we want to do weight sum plus equal 1 and partial result dot append char. In the second pass, we'll get rid of the opening parentheses not needed. And if char is equal to a closing parenthesis, then let's see. If weight sum is equal, let's see, if it's equal to 0, then we just want to continue. And in fact, we'll say less than or equal just for my sanity. So I know at this point it's going to be positive. And for here, it's positive. So we say weight sum minus equals 1 partial result dot append char. And that's it. And I'll just have a very quick guard statement. Cool. So, all right. The next piece of code before I write the helper function, we would be starting right to left, but if I'm going to do this in a way that uses a helper function, first thing I would have to do is we're going to have a reverse string, colon minus 1. And then we would...
This one will, it will continue to this line, isn't it?
Whoops, I forgot a continue statement.
Oh, okay, got it. I thought okay, go ahead.
Cool. All right, so now we have new weights. Our closing parenthesis should be 1, opening should be -1. And then I think most of the code would be duplicated, and so let me create a helper function. And then let me just put a little comment here. Do helper function. And then at the end of this, we would get some partial result. Let's see. Okay, and when I said reverse string, actually what I want is I want to join our partial result. Let me just say partial result. And I want to reverse our process string. Okay, and then down here we also get a new partial result. And what we want to do is, I think we want to reverse it first. So we say partial result is partial -1, or actually dot reverse. Actually, this won't return anything, so I can just have this as its own statement, and then return this dot join partial result. Okay, so let me write our helper function, and this will be f remove unnecessary chars. And it's going to take in some string. It's going to take in some weights. And what else is it going to take in? I think that might be it. So then the idea is I'm going to copy some of this code. We have our partial result up here. And we can copy this code as well. char in string, let's see, partial result is defined, weights, that's defined, string, that's defined, and then I need weight sum. Okay, weight sum is equal to 0, and then at the end of this, you return partial result. So what I can say is, down here on line 62, we want to say partial result is equal remove unnecessary chars. Our string is going to be our reversed processed string, and our weights is just declared right above it. Okay, and then let me just copy this, and I will comment out this code just because maybe I will want it in a moment if I make a mistake. And our partial result is going to equal remove unnecessary chars. It's just going to be the bare string and our weights. So I'm going to go ahead and try to manually test this, and let me see a good example. I want to remove opening and closing parentheses, so and also have some characters that are not either. Okay, so what we have is so I'm going to take this line 13, and okay, that will be our string. String equals, and let me bring this down closer to our balance parentheses function. And just for my manual testing, I'm going to take this snippet of code and I'm just going to remove it and put it elsewhere. Mm-hmm. I'll just put it at the very bottom in case I need it. Okay. All right. And let me get to, cool. So this is our string. And let's see, if not string, return something that's empty. We have weights is this dictionary. We have our opening, which is going to go to 1, closing, which will go to -1. Also, I just want to make a quick edit. Line 57. No, I've already switched them. Okay, so then, all right, our closing will be -1. And we're going to say partial result is remove unnecessary chars for, string weights. Cool. So inside remove unnecessary chars, our partial result is going to be this empty array. Weight sum is going to be 0. Okay, and for char in string, let's see, I'm just going to have a little pointer up here. So our first char, char in string. So our char starts at our closing parenthesis, and char not in weights is going to be false. So, and we are going to be on line 30, and weight sum is less than or equal to 0. So we are just going to continue. So then our next character is going to be an opening parenthesis, and char not in weights, and then we're going to go to line 26. So our weight sum is going to be incremented by 1. In our partial result, we're going to append this character. So I'm just going to put it up here. And then we are going to continue. So then our next char is going to be equal to A. Char not in weights is going to be true, so we're just going to append it and continue. So now I'm going to increment this. We have a closing parenthesis, and char not in weights is false. We're going to go to line 30. Weight sum less than or equal to 0 is false. So our weight sum is going to be subtracted by 1 to become 0, and we are going to append this character to partial result. And then char is another closing parenthesis. We've kind of gone through this case before. Char not in weights is false. And then we're on line 30. Weight sum is equal to 0, so we just continue. Then char is an opening parenthesis. and turn out weights is false. Line 26, we're going to increase weight sum to 1, and we are going to include our opening parenthesis, and then we're done iterating. We're going to return this as our partial result. So I'm going to say return this. Cool. So now what happens is that is our partial result. Our processed string is going to be opening a closing opening. And then our reverse processed string is going to be equal to opening, closing, a opening. Okay. And then we have new weights. We have closing goes to 1, opening goes to -1. And then we are going to run our function again. Partial result is remove unnecessary chars with our reverse process string. So I'm just going to copy these letters. It's a reverse process string in our new weights. Okay, so all right, let me just create a little space, and we have opening, close, a opening is our string. So all right, we have our partial result is this empty array. Our weight sum is equal to 0, and for char in string, so we're going to start with this opening. For char in string, char is going to start with our opening character, and char not in weights is false. It's definitely in there. And okay, I need to make an edit. On line 27, what I want to do is I want to say weights at char. And on line 28, weights at char. Okay, and for our initial case, the opening was +1, closing is -1, so it doesn't change our existing code. So we have our opening parenthesis. So we're on line 26. We want to do weight sum plus weights at the opening parenthesis is -1. Okay, so this is kind of a special case. I tried this helper function is kind of let's see. We have want to make a quick edit to this. So what we can do is we can say if weight sum plus weights char is less than 0, continue. And likewise, we can say, can add this code down here if weight sum plus weights at char is less than 0, just to make it generic. In fact, now that the actual code here is the same, we can just we can actually just remove the if char is equal opening or if char is equal to closing. And okay, so all right, so with this change, hoping that it didn't break any of the existing code. All right, so we're the first opening char weight sum is 0, and weight sum is 0 plus weights at char is going to be less than 0, so we're going to continue. So our next character is going to be the closing parenthesis. And okay, char not in weights is false. Weight sum is still 0 plus weights of char. That closing parenthesis contributes 1. So that's going to be, this condition is going to be false. So our weight sum, we're going to add that weight, which is 1. So weight sum now becomes 1. And then we are going to append to our partial result. So our partial result is going to start with a closing parenthesis. and then we are going to go to their next character. Our next character is A, and char not in weights is true, so we're just going to append it. And so our next character is going to be a closing parenthesis, or sorry, it's opening parenthesis. The opening parenthesis contributes -1. Char not in weights is false. Weight sum plus weights, it's going to be equal to 0, so this condition is going to be false. And then we're going to adjust weight sum to be 0. And then we're going to append this new character, the opening parenthesis, and then continue. We're at the end of our loop. We return partial result. So we end up returning this array with 3 elements in it. And now we are on line 85. We remove unnecessary characters. We're going to reverse this. So we say partial result is now equal to opening a closing, and this is an array, so has 3 elements in it, and then we want to return a stringified version of this. So opening a closing. All right, so that is our return value, just A surrounded by parentheses. And taking a look at our input, that looks like what we do want to return. So at least this passed that test case. Cool. Have any follow-up questions where I could talk about other edge cases and just make sure it's working appropriately?
Yeah, can you try this case? It's actually from the example. Try this.
Okay. So, all right, I'm gonna go through this a little bit faster. So, what's gonna happen is we're gonna remove unnecessary characters. The opening will contribute 1. So we start appending opening character. We have another opening character. I'll just also put our weight sum, currently 2. Our closing character, our weight sum becomes 1. We have an opening character, it becomes 2. We have a closing character, it becomes 1. And we have an opening character, and it becomes 2. So the first pass is going to not actually remove any characters. All right, and then what happens is we're going to reverse this. So reversed is going to be, it's going to look something like opening, closing, opening, closing, opening, opening. The weights are now reversed, so weights are going to be closing is 1, opening is -1. So as we process this, our result is going to be just from the next function call. We're going to, for the first character, we're not even going to add it because it's just going to contribute -1. For the second character, we are going to add it because it's going to contribute 1, and our weight sum is currently 1. And for the second character, we want to add it. Our weight sum is now 0. For the next character, it is opening, and this is contributing 1. So our weight sum becomes 1. Then we have a closing character that contributes -1. We can add it. And our last closing character, we don't add it just because it's it would, bring our weight sum negative. So our next partial result is that. What we end up doing is reversing this. So result becomes opening, comma, closing, opening, closing, comma. Okay. And then we end up stringifying this, so we get opening, close, opening, close.
Awesome. You said what's the space and time complexity again?
The time complexity here is going to be linear because each of our remove unnecessary characters functions is going to iterate throughout the whole string. The space complexity is also going to be linear because we have some, we have our partial results variable. We also have a reverse processed string. So yeah, linear time, linear space.
Okay, great. You are just in time. Actually, you finished a little bit earlier than the time limit, so that's great. Congrats. I would like to give you some feedback. Both
Sure.
of your questions, you got the optimal answer. The is palindrome is just you were able to identify the bottleneck, which is in the is palindrome, and you can make it a constant time. I'm sorry, a constant space, which is great. I also like how you communicate regarding to you didn't jump to the solution right away, but rather ask some clarifying questions. You have to remember to do that. Ask some clarifying questions, ask for constraints. That's great. You also got the edge cases to make the code simpler at the end. And I like how you organize your code into helper functions like you did for palindrome and the parenthesis. And then, yeah, your code is pretty easy to read. And when you test it, I really like how you test your code because it's pretty clear to me about how what you're thinking and running through the code because we are not executing the code. So running by hand and showing all the variables here, it is very, very clear. And yeah, this is the most optimal answer and within the 20-minute time mark. And the next one is, it's a pretty interesting approach that you have. You do the two scan forward and backward, and you came to the right answer. So yeah, that's the complexity linear. That's the most optimal answer. And how you test it, it is very, very clear to me on how this works. So that's great. By the way, for the second question, I would like to show you another way to solve this, which is using a stack. Yeah. So it's not necessary to make it in the interview because you got the optimal answer already. But I just want you to think about what would you do with a stack if you want to use stack for this to solve this problem.
Right. Okay.
Yeah. What do you think?
In that case, okay. A stack would let's see. We have opening parentheses, and if we have a closing parenthesis that doesn't match with an opening parenthesis, then we know that we could immediately get rid of it. At the end of the scan, I'm trying to think of how. I know we can get rid of closing parentheses with the stack. I'm trying to think of opening parentheses. So I'm looking at line 8. Maybe we could repeat that process on another stack. So we would do what I just described for the first stack. We'd have a second stack, and we'd pop each of these elements to that second stack and repeat that, and then pop all those elements and just convert it into a string. So that would be one approach.
I see. Okay. I have seen another approach of stack, which is keep track of the indexes of the opening parenthesis. And then when you come to the closing parenthesis, then you peek on the top of the stack and remove the index of the open parenthesis. That means if you come to the, let's say you are here. So you're here, and then you push this to the stack, which is number 0. You push number 1, and then you come to the closing. You can just pop number 1, and then by the end of the scan, you get the
I see.
Yeah, whatever that you have, which is opening. Actually, what
that's a simpler way of doing it.
Yeah, actually, what is left in the stack will be something that you can remove. So after you have done the scanning, you can remove all the indexes, and you have another array that you could put to keep the index of the extra closing parenthesis. For example, you have this one. You know that there's no the stack is empty, so there's no opening parenthesis. So you can keep this number 0 into the other set, and then you can remove them later. That's another way. But what you did is also pretty great. Yeah,
Cool.
we have about 10 minutes left. Do you have ask me any questions about the interview process, or if you really want another question, let me know.
Yeah, we could try another question. See how far I get through it in the time we have.
Yeah, it's just 10 minutes, so let's see if you can make it.
Yep.
I don't mind if you cannot make it. So, given a grid of characters, I give you an input, a string, an array of string. You find if each of these words exists in this grid. So, how to find it is the adjacent characters. So, for example, the word fast is pretty obvious, it's here, but the word book is also here, because if you start from B here, you can move to the adjacent character O, and then K above. The word good is also here, GOO and D above, but not the word but. So you just output whatever exists in this grid. You
Okay,
can use
I
each
see.
one.
All right. I can use what?
You can use each character only one time.
Okay, got it. So, all right. In this case, the time complexity, I'm thinking of doing kind of like a, what is it? A depth first search approach. Each depth first search is going to be, size of grid. Because we're going to have all, size of grid different start points. In this case, 4 times 3, which is 12. And, okay, so let's say we start this depth first search approach. We have, G. The total number of iterations is actually going to be, actually can be quite a lot. It can be up to size of grid again. It would actually be min size of grid and size of word. But we could also, look at all the different possible directions there. So I think it's really just going to be size of grid times size of grid. So I think I know how to do it. I'm just thinking about how I would, what kind of optimizations that I'd be looking to make here. So let's say there are a few constant time optimizations, like I can check the characters in the in the grid and just see if there are certain impossible results, like maybe the character count in the grid for each of the characters in a given word is less than it. So for example, if you had FAZ as a as a word, we know that we wouldn't need to compute that. But in any case, some of the code might look like for word in input, and we'll have our result is some empty array, and we can say for, let's see, row in grid, and let's see, we'll say for row in rows, we'll say rows is len grid, calls is len grid at 0. So for row in rows, for call in calls, and this is actually, I have to use range because rows is an integer, calls is an integer. And we could say if DFS, we have our grid, we'll need some visited set. Grid, word, start, grid, word, row column will be, the starting point. And we also want the word index. This result append word. By the way, will our input have duplicates?
The input, no duplicate.
Okay. And we'll say I, J, and word index. Okay, and also I need our visited character. And if word index is greater than equal len word, return true. And okay, if let's see, if I comma j in visited, maybe we'll return false here. And okay, so if grid at I at j is not equal to word at word index, turn false. What we do is we want to get a list of neighbors. There's another helper function. I'll say neighbors is get neighbors grid and two positions I and j, and for neighbor in neighbors, if let's see, BFS grid word, we'll say new I is new j is equal to neighbor. We have new I, new j, word index plus 1, and we want visited, but we need to update visited. So let's see, when we check if on 114 visited.add I comma j, so we don't use the same space twice. And cool, so if this return true, and if we get down here, we are going to return false for a get neighbor function.
I think get neighbors, did you mean to get the adjacent and within the bound of the grid characters, right?
Yep, that's correct.
Yeah, you don't need to implement that. I got it. So I think overall your approach looks good. So what would be your space and time complexity of this one?
Okay, so let me just calculate this. Let's say our grid is n cross m, and words is w in size. So that's on lines 12 and 13. So we have time and we have space. All right, so as far as time goes, let's see. We are going to iterate through words, so it's w times something. And we're going to iterate through row and column, so n times m, just to start. And we're going to call DFS. The most that we can continue with DFS is the size of the word, or the total number of grid spaces. So I could say min of n times m, or let's see, when I say the length of the word, we actually are going to look at our neighbors. Let's just
to make it a little
times m.
simpler, the length of each word is constant. Let's say, like they're always 4.
Okay, got it. All right, so if it's always 4, then it just comes down to how many spots can we explore. If we have 4, I think using n times m is probably the safer approximation. Okay, so our time is going to be n squared m squared times w. W is the total number of words. And as far as space, so when we do DFS, we have our visited set, and it's going to grow a bit in size. So our visited set can be at most n times m in size. We also have the DFS call stack, and that can also be n times m, so DFS call stack. and our result is going to be size W, up to size W result. And these exist separately of each other. So I think it's going to be n times m plus W space.
Okay, cool. I think you got it. So yeah, great job. I think you got all the communication, the problem solving, writing, translating your idea into a good code, clean code, and good testing and analysis. I think you will nail it. Good luck.
Thank you. Appreciate it.
Yep.
All right. Goodbye, hamburger.
All right. Goodbye, Raven.